Okay, now we're going to do a measurement with the RiverSurveyor, and we're going to use the RiverSurveyor Live Windows software. To begin, we're going to open the RiverSurveyor Live program by clicking on the icon. The next thing that we're going to do is we're going to connect to the RiverSurveyor. We're going to select the correct COM port and press connect. We're going to select the M9 and press connect. Now the Bluetooth I have on my laptop is connected with the Bluetooth that's connected to the M9. The first thing, as you can see, the screen here, it's ordered in step 1, step 2, and so forth. So step 1, I'm going to input the site information. Okay? We're on the Pongolo River. The station number. And once we put in our site information, we can press OK. Now you can see the site name, the site number, or the station number, the location, the party, which is actually, you would just put your name here and whoever's doing the measurement with you, the boat motor, in this case we're using the hydroboard, measurement number 1, and just some comments. We're actually here today on the Pongolo River to make a high flow measurement. The next one, it identifies the instrument that I'm using. I'm using the RiverSurveyor M9, serial number 765. The particular firmware version is 0.76. So now, to program the system for measurement, I'm going to program in the transducer depth by clicking Change System Settings. It's a transducer depth of 7 centimeters, which we've measured. The screening distance won't be used on the hydroboard. The screening distance is the distance if I want to blank out an additional distance, maybe because I'm beside a large boat and I'm getting some flow interference. The salinity, we're on a river here, an upland river, so the salinity will be 0. The magnetic declination. This is important when we're using GPS. We have to set the correct magnetic declination. The magnetic declination for this site is actually minus 19.3. I got that value from a map. There's several ways that you can get the magnetic declination. Typically, it's from a local map or even from a computer model that you can download from the internet. My track reference, I actually can select bottom tracking. I can select GPS GGA. Or I can select GPS VTG. My depth reference, I can select to reference either the vertical beam or bottom track, the 4 beams or 8 beams from the bottom track. In this case, I'm referencing bottom tracking and the vertical beam. The coordinate system will typically always stay at E and U. So, just to review, really to program the system, I have to put in the transducer depth and then magnetic declination, because I'm actually going to be collecting GPS data along with this data set. And I press OK. Going a step further, I can change the measurement settings. If I know a rated flow, I can put in the flow rating for the day or for the measurement. And I can come back after the measurement and change the measurement quality. Okay, measurement quality is basically your assessment of the conditions that you measured in that day. Was it a very bad cross-section? Was there good flow? Was the flow changing? Things like that can actually affect the quality of the measurement itself. We can select the left bank or the right bank. Again, the left bank would be, we identify the left or the right bank by looking downstream. And once we look downstream, the left bank is to my left and the right bank is to my right. The next that we have here, we have the recorder. And this will actually be done in post-processing. Once we've collected our data, remember that the data is actually stored on the ADP itself. That's to avoid data loss. If we have a transmission break, we don't lose any data. Okay, so you can see I have data, actually quite a bit of data here on the recorder already from previous measurements, but it's flash memory. It's 8 gigabytes. It's going to store thousands and thousands of measurements, which you would never typically keep that much on the recorder, but there's plenty of room for you to collect data. I can download all files. I can just select particular files to download, and then I can even format the recorder. Again, it's flash memory. Once I format the recorder, I basically clear it of any measurements that I make. The last step here, I can set we can perform a compass calibration. This is a utility section. I can set the time. Okay, you can see I can use the PC time. The time here is correct. I can do a beam check. A beam check, it checks the signals in the water. If the system's not in the water right now, but if I wanted to check the beam strengths, I can check that. I can run a system test. I can upgrade firmware, and I can actually select my GPS option. In this case, I'm using an RTK GPS system. So I can actually, right now the application is set to RTK. If I didn't bring my base station that day, and I wanted to use just the differential correction, I can click Change the Differential. Okay, so what I've just explained to you is how we actually program the instrument to measure. We put in the pertinent site information. This identifies the system we're using. We input basically the transducer depth and the declination, make sure our track references are correct, and we're basically ready to go. Then the very next step will be to start a measurement.